Hello students, let us continue our discussion regarding the requirements engineering. Now we will study about software requirements document. What are the things that we are going to store in a document and who is using it, everything will be saying in the upcoming slides, right? The software requirement document is the official statement of what is required of the system developers, right? Whatever is required by the system developers, everything is included in this software requirement document. And it should include both a definition of a user requirements and a specification of the system requirements. User requirements will be explained in terms of a normal language, right? But specification about what system has to do, that will be explained in depth. It is not a design document. Okay, what we have to understand is whatever the requirement document we are considering over here, it is not a design document. As far as possible, it should set off. It's nothing but a set of things what the system should do rather than how it should do. Okay, in this software requirement document, what we are going to have is what the system should do, and we are not going to concentrate on how it should do. It is depending on the designers. Now we will see about agile methods and requirements. What the people who are making use of agile method, what they say is, many agile methods argue that producing a requirements document is a waste of time as requirements change so quickly. What they're arguing is, if you're following a method of development of a particular software, wherein first you develop a software requirement document, then you go for developing the things. When you are developing this software requirement document, at that time someone might come up with the new change, right? Then how you are going to cope up with this? So that is their main argument. Many agile methods argue that producing a requirement document is a waste of time as requirements change so quickly. The document is therefore always out of date. What they say is, whatever the document we are going to have, it will be out of date. Methods such as extreme programming use incremental requirements engineering and express requirements as user stories. During the development of a software, if you're following a agile method, then how you're going to write the document is you're going to maintain a document, but the thing is, you will not have a complete document what the system has to do. You will be developing a small requirement document wherein you will be including what the system has to do in the next increment, right? This is a practical for business system. Whatever the extreme programming or the agile method that we are following is, it is useful for the business system, but problematic for system that require a lot of pre-delivery analysis. Example, if you're building any critical system, then you cannot go with the extreme programming or the agile methods. And system developed by the several teams. If you are developing an application wherein many teams are involved, then again you cannot go for this extreme programming. You need to develop a document, then you need to pass it to all the teams, then they start up building the things. Now we'll see who are the users of the requirement document. This requirement document is used by system customers, managers, system engineers, system test engineers, and the system maintenance engineers. But the way in which they are going to use is different. Let us see about our system customers. Why they require a document? They require a document because it specifies the requirements and read them to check that they meet their needs, right? Whatever is required by the customer, whether it is present in the requirement document or not, they can check it by looking at the document. Customers specify changes to the requirements. If anything is missing or something has to be added, then by looking at the document, they can say that, okay, this is the change that has to be done, right? So document is helping them in some way. Then why requirement document is required by the managers, right? Managers use the requirement document to plan a bid for the system and to plan the system development process. Either this document is used for bidding purpose or it is used for the development of an application. Then system engineers, why they require is they use this requirements document to understand what system is to be developed, right? They are the engineers who are developing the things, so they'll be looking at this document and they are coming up with solution, right? How it has to be developed and all. Then system test engineers, they use these requirements to develop a validation test for the system. Then we have system maintenance engineers. System maintenance engineers, why they require this document is they use these requirements to understand the system and the relationship between the various parts of a system. Requirement document variability. That is, whatever the requirement document that we are going to develop, it is not fixed, right? It depends on what kind of application we are going to build, who is building it, and whether we are following the incremental model or waterfall model, or what kind of model we are following. Based on that, requirement document is going to vary, right? Information in requirement document depends on type of system and the approach that is used for development. Next thing is system develop incrementally will typically have less detail in the requirements document. If you're following an incremental development, then in the starting will not discuss much thing in detail. So in the requirement document, less information will be present. Requirement document standards have been designed. For example, there is a standard known as IEEE standard. These are mostly applicable to the requirement for large system engineering projects. If you're building a project which is involving many people, and if the complexity is more and all, then you can follow this IEEE document for building the software requirement document. This is structure of a requirement document, right? What it involves is first chapter involves a preface. In this, what we are going to have is this should define the expected readership, right? Who are going to make use of this, whether the user is using, the designers are using, testers are using, or the managers are using, who are using it, right? So that is explained in the preface, and describe its version history, right? When we develop an application, applications will be having a versions, right? We are Windows, like if you consider example of a Windows 8, then we have 8.1, 10 Windows, all these things, right? The versions tells us that we are in the current version, right? Including a rationale for the creation of new version. What is the reason behind for going for the new version, that is included. And apart from that, a summary of changes made in each version. What is the change that you have done in each version, everything is explained in this preface. Then we have a second chapter, that is an introduction chapter. This should describe the need for the system, why it is needed, why we are developing this particular application. It is explained in this introduction. It should briefly describe the system's functions and explain how it works with other systems. And apart from that, it should also describe how the system fits into the overall business or strategic objectives of the organization commissioning the software. Everything is explained in this introduction. Then we have glossary. They should define the technical terms used in this document. Whatever the technical terms we have used in this particular document, we should have an explanation of that. You should not make assumptions about the experience or expertise of the reader. That is, if there are some words, you should not assume that it is known to everyone, right? Even though you know that it is known to everyone, but there might be some people who don't know a meaning of the particular term. So you should have a glossary of that. Then we have user requirements document definition. Here you describe the services provided for the user. What are the services that are being implemented in this particular application, that has to be explained in this, right? The non-functional system requirements should also be described in this section. This description may use natural language, diagrams, or other notations that are understandable to the customers, right? When you are writing the user requirement definition, what you can do is you have liberty, right? There are many things you can make use of. One thing is natural language. You can write it in natural language. Then you can make use of diagrams or some other notations which you can use over here, so that the customers can understand, because user requirement definition is dealing with the customer, right? Then we can also include product and process standards that must be followed, should be specified. Then we have a system architecture. This chapter should present a high-level overview of the anticipated system architecture, showing the distribution of functions across system modules. Then architectural components that are reused should be highlighted, right? Here you need to have overall architecture, and what are the things you have reused that should be highlighted. Then we have system requirement specification, which is generally used by the developers or the designers. This should describe the functional and non-functional requirements in more detail, right? Why it should be explained in more detail is because it is used by the developers or the designers of the application. If necessary, further detail may also be added to the non-functional requirements. Regarding non-functional requirements, you can go for adding much more details, and interfaces to other systems may be defined in this system requirement specification. Then we have system models, right? Here you can make use of many models, right? There are multiple models like object models, data flow models, semantic models. All these models can be used for describing the overall uh, architecture of a particular system. Then we have system evolution. They should describe the fundamental assumptions on which the system is based. Then and any anticipated changes due to hardware evolution, changing user needs, and so on has to be explained over here, right? Why we need a evolution? Whether the hardware has worn out, or user is coming up with new requirement, or any other reason. What is the reason that has to be specified in this system evolution chapter? This section is useful for system designers as it may help them avoid design decisions that would constrain likely future changes to the system. Right? Why it is used by the designers is designers make use of this system, and they are going to alter the system in a such a way that in future if someone is coming up with new requirements, that can be easily adapted over here. Then we have appendices. This should provide detailed, specific information that is related to the application being developed. For example, hardware and database description. Everything should be explained in detail about over here about the hardware and the database that we have used. Hardware requirements define the minimal and optimal configurations. Right? When you are dealing with the hardware requirements, you have to explain which one, like what should be the minimal and what is the optimal configuration that you can have for the particular system. Then database requirements define the logical organization of the data used by the system, and the relationship between the data has to be explained in the appendices. Then we have index. Here we can have many indexing, like a normal alphabetic indexing, or else you can have indexing of the various diagrams, indexing of the functions, and so on you can have in the index. Next one is about the requirement specification. What is a requirement specification? The process of writing down the user and the system requirements in a requirement document is nothing but a requirement specification. Here you are going to explain each and everything like user requirements and the system requirements. User requirements have to be understandable by end users and customers who do not have a technical background, right? When we are writing a requirement document, we should split it into like user requirement and the system requirement. User requirement is used by the end users who don't have much more technical background, and system requirements are more detailed requirements and may include more technical information because it is used by the designers for designing the application. The requirements may be part of contract for the system development. Sometimes what is going to happen is whatever the requirement document which we are going to write over here, it is used for the contract in the some of the projects. It is therefore important that these are complete and they are consistent as possible. What are the ways of writing this requirement specification? First one is about the natural language. Here we can make use of any language like English language, wherein each sentence explains regarding a function that has to be present in the application that we are going to build. Then we have structured natural language. The requirements are written in natural language on a standard form or template. Here what we are going to have is we will be having a form wherein we have to fill the each and every field over there. Then design description language. This language was used in the earlier days, wherein which is similar to the programming language but will not have each and every syntax over here, but which is similar to the programming language, but nowadays we are not using this. Then we have graphical notations. Graphical models supplemented by the text annotations are used to define the function requirements for the system. For example, UML case, use case diagrams, sequence diagrams. These are the diagrams which are commonly used for the graphical notations. Then we have mathematical specifications. If you are writing each and everything in a sentence, then there might be some ambiguous statements that are going to arise. Because of this, what we can have is we can have a mathematical model. Mathematical concepts can be used, such as finite state machines that you are going to study in your ATC subject, right? So which is giving us a clear idea about that. But the thing is, although these unambiguous specifications can reduce the ambiguity in a requirement document, most customers don't understand the formal specification. The customers cannot understand, but the designers are going to understand regarding this mathematical specifications. They cannot check that it represents what they want and are reluctant to accept it as a system contract. Like as I said, the customers cannot understand this mathematical specification, so they will not accept this as a contract. This is also possible. Requirements and design. In principle, requirement should state what the system should do and the design should describe how it does. Right? This is clear, right? Requirements has to explain what the system has to do and how it has to be done. It should be explained in the design phase. In practice, requirements and design are inseparable. They go hand in hand, right? We cannot separate this is a design phase and this is a requirement phase. No, right? They go hand in hand. A system architecture may be designed to structure the requirements. Then the system may interoperate with other systems that generate design requirements. There might be a interprocess communication between the various components, right? The use of specific architecture to satisfy non-functional requirements may be a domain requirement. So these are the things that are regarding the requirements and the design. One important thing is we cannot separate design and requirement phase. As we have seen, there are various ways of writing the specification. One method is natural language specification. Requirements are written as natural language sentences supplemented by diagrams and tables. You can make use of diagrams and tables, but the main thing is a sentence is used for writing the requirement, and used for writing requirement because it is expressive, intuitive and universal, right? Whatever the natural language which we are using, here we can easily express the things whatever is required. Then this should whatever the requirement document we are using, this should be universal. It should be understood by everyone. This means that requirements can be understood by users and the customers. Now, what are the guidelines for writing the requirements? First one is invent a standard format and use it for all requirements. We should make use of some standard format so that throughout the development of any application we can go with this. We can stick to the particular format. So it is very easy for understanding the things. Use language in a consistent way. Whatever the language we are using, it should be used in a consistent way, proper way. Use shall for mandatory requirements. Whenever you are writing something mandatory, make use of word shall, and should is a word that you are making use of for desirable requirements, whether you can include or not include, no problem with that. Use text highlighting to identify key parts of the requirements. Whenever you are explaining regarding the key points, make use of highlighters. Avoid use of computer jargon, that is complex terminologies you should not use while you are writing the requirements. Then include an explanation of why a requirement is necessary. You should write the reason behind why you are including this requirement in this particular application. What are the problems with this natural language? The first problem is lack of clarity. Precision is difficult without making the document difficult to read. Here what is going to happen is you might write something and the other person, the designers will think it in a different way. That is also possible. Requirement confusion. Function and non-function requirements tend to be mixed up. While when we are dealing with security, it might be when we are dealing with security issues, it can be either treated as a functional requirement or it can be treated as a non-functional requirement. So that is a requirement confusion. Then requirements amalgamation, that is several different requirements may be expressed together. While a requirement is given by the customer, he might mix up many requirements and he might state it in a single statement, so it becomes a single requirement, but actually it is a combination of many requirements. This is an example of requirement specification, right? The system shall, here we have used a term shall, that is a mandatory. Shall measure the blood sugar and deliver insulin if required every 10 minutes. Every 10 minutes, the insulin pump system has to check what is the blood sugar level. If it is more, sugar level is more, then insulin has to be injected. So that is the statement written over here. Then we have another one, requirements, right? What is that? The system shall run a self-test routine every minute with the conditions to be tested and the associated actions defined in table A. We will see regarding the table A later. Right here, what the system has to do is system has to check whether all the functions are working properly. Then we have structured specifications. Structured specification is nothing but it's an approach to writing requirements where the freedom of the writer is requirements writer is limited and requirements are written in a standard way. Uh, this is a little bit different from the natural language specification. In structured language, what's going to happen is um, here we are going to write a statement in a such a way that we'll be having a particular structure. You cannot deviate from that. But in a natural language, there is no restriction. This works well for some types of requirements. Example requirements for embedded control system, but is sometimes too rigid for writing business systems. Right? When you are dealing with when you are dealing with the business system, this will not work. Form based specifications. Here we have definition of the function or entity, descriptions of the inputs, where the inputs comes. These are the things that we'll have in a form based things. Descriptions of outputs and where they go, and information about the information needed for the computation and other entities used, descriptions of the actions to be taken, pre and post conditions, the side effects, each and everything will be in a form. We have to just fill out the entities. You can see the structured specification of a requirement for an insulin pump. Here what we have is um, this explains regarding the things, right? Function. What is the function of this application that we are going to have? Compute insulin dose, right? What is the safe sugar level? This is going to be calculated. Then description, how the working of the system is. It computes the dose of insulin to be delivered when the current measured sugar level is in the safe zone, that is between 3 and 7 units. What are the inputs given to this particular setup? Current sugar level reading, that is R2, the previous two readings R0 and R1. Then what is the source from where the readings are taken? Current sugar reading from the sensors and other readings from the memory. What are the output, right? The output is the compute dose. How much amount of insulin has to be delivered? Where the information passes is the information passes to the main control loop. Here we have the action. Compute dose is 0 if the sugar level is stable or falling. If the sugar level is stable or it is falling, no of inducing any insulin. Or other condition is if the level is increasing but the rate at which the increase is increasing is decreasing, then also will not insert any insulin in the human body. If the level is increasing and the rate of increase is also increasing, then compute dose is computed by taking the difference between the current sugar level and the previous level divided by 5 and rounding the result. If the result is rounded to 0, after calculation, if the result is 0, then what we do is we compute the dose in a such a way that minimum dose has to be delivered to the person. What are the requirements? Two previous readings so that the rate of change of sugar level can be computed. This is a requirement. Apart from that, we have a precondition. The insulin reservoir contains at least a maximum allowed single dose of insulin. This is a precondition. Every time this has to be checked whether we have a maximum dosage level that can be inserted in a human body or not. Right? What is the post condition? R0 is replaced by R1 because the current reading R0, it becomes the previous reading in the next step, right? And R1 is replaced by R2. Then whether we have any side effects? No in this. Then we have a tabular specification. We are making use of your tables, right, which is used for supplementing the natural language. Already we have studied regarding the natural language specification, wherein we are making use of a language. We are writing the specification in terms of sentences. Apart from that, we can make use of this tabular specification also for supplementing that. Particularly useful when you have to define a number of possible alternative course of actions. When we have multiple alternatives for this, then we can make use of a tabular column. For example, the insulin pump system bases its computations on the rate of change of blood sugar level, right? Everything is dependent on this rate of change of blood sugar level. If the sugar level is increasing, there is a different step to be taken into consideration. If it is stable, then we are dealing with something else, right? And the tabular specification explains how to calculate the insulin requirement for different scenarios. This is a tabular column, tabular specification of computation for an insulin pump. Here we have conditions. First one is sugar level is falling, right? R2 is less than R1. What does it mean? Sugar level is falling. If sugar level is falling, what is the action to be taken? Compute dose is 0. Sugar level is stable, right? R2 is equal to R1. Then the sugar level is stable. Then compute dose is 0. And apart from this, sugar level is increasing and the rate at which the increase is increasing is decreasing, then we will come to a conclusion that compute dose is 0. But if it is the other case wherein sugar level is increasing and apart from that rate of increase is also increasing, then we are going to compute the dose. How we are going to compute the dose is R2 minus R1 divided by 4. Then we will round it off. If rounded result is 0, then compute dose is minimum dose. Regarding requirements engineering, we will be studying this in next class.